think we're gonna see some of these constraints and examples how they perform on the platform, right? So
Yeah.
I think it's probably a good time now to connect and see some data in action.
Right. So yeah, let me share my screen. Okay. Share. So I'm going to share a demo account, but you can also go to benchmark buffers and see what I explained and how it works. And this is if you want to read little bit more about the engine I was just mentioning, like the Times Foundation, the Microsoft, the Meta, and the two statistical models. And you have it. It's very short and it explains very good and gives you metrics as to see where are you in benchmark, worldwide benchmark. There is a great article here about forecasting and what's considered like in core replenishment, like basics, basics in fashion. So 2030 WAPI, that's industry typical, and so you can read about it. So you have everything here. And if you go here to the try benchmark, you can do whatever I'm doing. Okay, so this is basically the system. Now I'm in the part of the planning in the backtesting benchmark. Okay, and that's what I'm going to show. And yeah, so I'm going to like select whatever the first SKU. I'll set all the defaults with no any changes. And here what happens. We run 5 algorithms. Each one of them do backtesting for the last 9 months. And this is what the system found. I'm going to zoom in. Okay, let's zoom in a little bit. And here what we see here, I'm going to turn off the exponential smoothing. So this is the Times Foundation. This is Google model. So as I told you, remember, I did here actually 9 months backtesting. So this is the backtest window. So I did the backtest. So according to the actual sales of that product, what's that product? I don't know what it is. Let me see. So this is the product, okay? This is the product, and this is its price, 129. Okay, and according to the actual sales on October 25, that's in the past, obviously, they sold 257. Now remember, this is from the central warehouse. This chain has around 250 stores. So what we are seeing the demand from the warehouse. It's not from a specific store. So 25, and the Town Foundation forecasted 254. The next month it was very close, and then it has like a mistake, like 300, and it made it 195, 197, and so on. And this is what we do with the backtesting for each one of the algorithm. You can see how it predicts compared to the actual demand that we know about. We have it until June 26th. Okay, and you can see here the ranking, who got the best score, and you can read how the score was done. Okay,
so Pini, it's not playing poker. It actually has like significant data behind it.
Exactly. So, for example, if I'm looking here on the that's Microsoft LightGBM, I took a random SKU. You can log in and do. There are 5,000 SKUs around here. You can choose which one of them, and you'll see the same data. So, for example, the model found we didn't load it. That price is actually this price 129. It's a good price, and that's impact on the forecast 1.7%. And the color black, you see that brings 11% compared to the same style for that product, while the gender, season, and category does not have any impact on the forecast. Then we see that the recent sales momentum, there was a sales momentum that brought it by 0.75%, and non-zero days, that's 2.8%, and I'm not going to go to each one of them, but each one of them, the calendar month made the impact. Now, what's interesting here is that to see how to find which algorithm found the best forecast based on the benchmark. And in this case, I choose the first one, that's the exponential smoothing. And if I see here, there is a rating system that score each one of the algorithms. Okay. And if I go to the forecast, now I'll go to the future. So what happened is that we run all the catalog, we find the winners. In this case, this SKU will be the winner. And then this is the algorithm that's going to do the forecast forward for the next period. So here it is how it looks in the past. And then this is what the system predicts for June 26th, from August, and for September. I put it like it's like lead time 60 days and order frequency 1 month. So that's actually become like 90 days, 3 months of forecast. Okay.
Okay. So we have a question for you, Pini, I think. How from Julia, how does the model handle products that experience stock out issues in the past, resulting in sales being below their true potential?
Yeah. Okay, so there are two ways. So here, if I come here, there is like, if there was, I'll take the simple case, like there was, a big event, let's call it a AA, that was unknown before forecast. I'll set it to no, and I'll put it, let's say, April 2026.
Okay, before we jump into that, there is practically, if I understand, there is a whole feature to manage events.
Yes.
Correct. So
right. So the thing is that when it's an unknown event, you have to feed the system, because then the system is going to, I'll test it again, the same one. The system is going to ignore that day. So you see here what it says, days excluded, because I choose those 10 days. So we took out those 10 days from building the, although it's not Julia's question, but I'm getting there. So we know to exclude those days because unexpected event. Okay, so that's one thing. If the stock level was 0, it's count as an unexpected event, and it will take out from the history sales. So we delete those days without inventory in the warehouse, because we know you don't have the potential to sell.
Okay, so the system understands that there was an exception, so substantially, yes.
Of course. Okay. So because what you are doing here, think of it like that. It's a little bit details, but I'll try anyway. So we are trying to do a forecast of 90 days, but let's say in those 90 days, there was 30 days that there was stock out, meaning you didn't have stock, meaning you didn't have sales. Okay, obviously you didn't use the product potential because you didn't have sales, obvious. So what the actual system will do, it will go not 90%, it will try to do like 120. It will increase the window of doing the forecasting. It's a very known situation, how we handle it.